Okay, read for me where it says probably horizontal what?
Horizontal stretching and shrinking of graph.
Okay, and was the first one horizontal? Hang on. Was it stretching or shrinking?
Stretching.
Stretching. Guys, this is the last one we'll be doing. Now notice he did not say horizontal shifting. He said stretch it this time. That's a little different. Now describe what it says on the handout.
To graph f of cx.
Oh, hang on. F of, oh, a C inside, CX.
Where c is greater than 1.
Uh-oh.
Shrink the graph of y equals f of x horizontally by a factor of 1 over c.
Shrink by a factor of 1 over C. Of all the transformations, I think Mr. Park would agree with me, this is one you gotta be careful with. That's why I saved it until after we took a break here. And we're gonna try this. He says, Professor, it looks like that. That's what they want you to do. So guys, I'm gonna try to sketch. And it's gonna make some sense here. F of Cx, let's write this as y is equal to, here it goes. Let's make it this. I replace C by 3. And he says, as long as C is greater than 1. So we'll try an example, I'm trying 3. I know and you know, I know that example really says that's 9x squared. And you know it's going to graph into something with a parabola. The truth has something to do with the parabola, yeah. But the reason I did this, to see what on earth that statement he read to us is telling me, let's do this. Let's graph the parent graph. And all mine tonight have been x squared graphs, parabolas. Like I said, this will be the last basic one we'll do. Guys, let's make it look like this. This is my parent. That's just a basic y is equal to x squared graph parabola. Now, I want to graph this. Now, if I base it on what he said, and this is a strange one here, of all the transformations, if I base it on what they're telling me on the handout, says now, C is greater than 1, yeah, my C inside there is greater than 1. Shrink the graph should be shrunk now. We'll see what they mean by when it should be shrunk. By a factor of 1 over C, where my C is 3. So I'm trying to shrink this graph by a factor of 1/3, 1 over 3. Can anyone tell me, and this is the hardest one, what can I do to show that this basic red graph parabola is supposed to be shrunk horizontally by a factor of 1/3? And before let me just give you a glimpse of what it may mean. When I finally graph it with the help of a student here, that means my red graph is going to be squeezed in horizontally if I do it correctly. That's the effect that this is going to have on that parent graph. It's going to be horizontally shrunk. Now, how can I get that effect? Samantha has her hand up. I got also, hang on a second.
I'm thinking maybe take the points of this graph and square, maybe square it.
Getting close. Look at that. This is the hardest or the most strangest one of all the transformations. And it is going to close that parabola up horizontally. That's what it's supposed to do.
Oh, maybe not multiply by 2, maybe divided by 2.
We're getting close. We're getting close.
No, I think so. If it was x squared, then which is the point 1 would be on 1, 1. Does that make sense? But if you take point 1 with this function, it would be at 9.
I got you. Oh, I see what you're saying. You're going to go ahead. In your mind, it's 9x squared.
Yeah.
Right.
Exactly.
Okay. I don't want to expand it out. I want you to get exactly what he read to me. I'm going to leave this 3x quantity squared. I know it's not x squared. So I'm going to leave it like that so I can really look at exactly what the handout says. It says I'm supposed to shrink the graph by a factor of, this is the strangest one, one over C, and I'm using my C for my example to be a 3. So I'm supposed to try to show a shrink of 1 by 1/3 horizontally. Can anyone tell me in this accelerated class, what might I do to get that effect? Because it's supposed to close the graph in horizontally. Can anyone tell me what might I do to get that effect? Samantha, I'm going to you.
Well, a lot of you are probably wrong, but if you're shrinking it by like horizontally, that means you just have to adjust the x.
Ooh, tell us that again. She says,
If you're shrinking it by moving it horizontally, you have to just adjust the x value.
you have to adjust the X. You're dealing with only the X. Now tell me, please, to finish it up,
Can't you just reduce it by 1/3?
you're supposed to adjust it by 1/3. Now what does that mean? I'm supposed to go to my parent graph. I'm gonna plot a few points on the parent graph. And she says, I like that word adjust. In this case, you're gonna multiply the X coordinates, just the X coordinates. My points that I plan to place on there in a few seconds. Multiply, that's the adjustment, multiply the X coordinates by 1/3. Now, right now at this point, I know everyone in class would accept this. This point is supposed to be representing 0, 0. That's the vertex. I could throw a point out here with Samantha's help and call that 1, 1. Directly across, I could do another one and call it -1, 1. I think everyone in class would agree. I could place 2, 4, -2, 4, 3, 9, -3, 9. Is that true, guys? I think these three will be enough. Now she says, adjust it, professor. Go to the X coordinates, because I'm going out horizontal, let's just, with the X. Go to the X's of those 3 points you were trying, and multiply by, look at this, they say, multiplied by what? 1 over C. That's the shrink factor. In this case, what? 1/3. So guys, if I go to my first X coordinate, which is -1, and now multiply that by 1/3, it becomes what? -1/3 up 1. Does that take me -1/3? Let me do this so we will follow it. This is supposed to be out to -1. This is supposed to be out to 1. Now if I adjust this and multiply the X coordinate by 1 over C, where my C is 3, by 1/3, this now becomes -1/3. The X does, up 1. So -1/3, guys, up 1. Let me use a different marker. Let's hope it works. You gotta see what's happening here. -1/3 up 1, right in here somewhere. This point is 1, 1, right now. It's on the parent graph, 1, 1. She tells me to adjust it. How? This time multiply the X by, again, 1/3. So guys, now this point becomes what? It becomes 1/3, 1. So out 1/3 up 1 is somewhere, let's say, in here on the other side. There. My 0, 0 stays right where it is. So if I'm gonna multiply by 1/3, 1/3 of 0 stays right where it is. So that stays here. Connect these, and please tell me if I even do this like this. If I compare the red to the green, does it look like maybe the red has been squeezed in horizontally to form the green? That's exactly what's supposed to be happening. That's a horizontal shrink. Shrink the red, squeeze it in, and finally you'll get, in this case, the green. Make sense? That's called a horizontal, in this case, shrink, was it? A stretch by a factor of 1 over C. Yes? No? Okay, now, to close it down, I want to know what the other one is, to close down. Describe the other one.
To graph FCX where 0.
Oh, now, so they call this horizontal shrink here?
If you have
Did we get these mixed up? Is this
yeah,
shrink?
that was the shrink.
This is shrink, okay, this is shrink, we got that down. Not the stretching. Okay, horizontal shrink. Now this one is the horizontal stretching, I think. Okay, guys, describe that to us.
So it says to graph F, C of X, CX, C is greater 0 and
Okay.
less than 1.
C is greater than,
Oh, sorry, so 0, and then C is greater than 0. So 0,
oh, it's caught between 0 and 1?
yeah,
Ah, there you go. You tell me like this. Right?
correct.
And therefore, if that happens, anything else about the C? I'm supposed to what, stretch it by a factor of what?
1 over C.
Okay, stretch. This is the strangest one, stretch by 1 over C, not shrink, stretch by 1 over C. Whoa. Okay, guys, I'm just try to use a different color, if my colors will hold up here. I'll keep this graph, I see the ring was the horizontal shrink, squeezed it in to get the ring graph. Now, the next one says, if we've written it down correctly, is a horizontal stretch, and I'd like to, yeah, I see a color like this, let's see if this will work, guys, let's try this. Can anyone tell me what might, Samantha explained this one so perfectly, what might this mean to do to get the effect? Now keep in mind, horizontals associated with the x's. And it says to do it, stretch it by 1 over C. And I'm going back to my parent graph. I'm going to use those same 3 points on my parent graph. Negative 1, 1, 0, 0, 1, 1. And this time do what to them? It says stretch it by a factor of 1 over C. No, hang on. Hang on. Let's try this. We're trying to graph this. Where I think you said the C, right here, this number should be caught between 0 and 1 in this case. Is that true? So this time we're trying to graph f of 1/3 x. The last one we graphed what? F of, where was it? 3x squared. Wow, okay. So let's write this as y is equal to make it look better. This last one, and again, I'll keep it into a parabola. So guys, I'm back into a parabola, it looks something like that. And I met the condition here, I made the C inside here. He says, please make the C fall between 0 and 1, which I did. And they're telling me if that C is caught between 0 and 1, it looks like that. What should that do to my parent graph? Stretch it horizontally, we'll see what that means, by a factor of 1 over C. Now, can anyone tell me what would I do back on my parent graph, the red one? I'm gonna try to do it in orange. To get a factor of effect of 1 over C. Where my C in this case is a strange number, it's 1/3. So what factor am I looking at if I place 1 over 1/3? What is 1 over 1/3 going to give you to begin with?
Maybe we adjust the y values,
No, we're going,
but still x values.
yeah, the x. We're going to adjust, just like Samantha told me on last one, adjust the x.
Multiply by 3,
Look at that. Why?
because it's the opposite as the shrink,
It says 1 over C, and C in this case is what, 1/3?
1/3,
So 1 over 1/3, guys, please tell me is 1 divided by 1/3, 3.
3.
So this time to get the effect, I need to go to those 3 on the red there and multiply by what? 3? Yes or no?
Yes.
Woo!
Yeah.
Jeez. And watch me mess up myself here. Trying to keep track of all this. Does that make sense though? So somehow I gotta get the effect by multiplied by 3. Now, let's step back and look at it. Because I know and you know right now that thing says 1/9 x squared. Does it? That's what it says, 1/9 x squared. I wrote as 1/3 x quantity squared to make it fit his description here that we're talking about. Okay, whew. Guys, help me out. All right, you tell me now this was -1, 1. Is it now -3, up 1? I'm gonna multiply the x by 3,
Yeah.
as I heard. So that means go out. To here, is that true? -3, and go up 1, please tell me, I don't wanna mess up. Is it now here? This point. Is it now there? Is it -3, 1? Don't let me mess up. Thank goodness. 0, 0 is gonna stay right where it is. Multiplying by 3. This 1, 1, if I multiply by 3, the x, and now it becomes 3, 1. So that means move out 3, up 1, and we'll get that out of the way, I hope. Let's see if you guys will agree if that is what it means. You think it does? I got those 3, is it? Now, by the way, if I connect those 3 in the orange, I hope you guys can see the orange there. Is it still gonna be the shape of a parabola? I'll have to really make it look like it's supposed to look. Is it coming down like this? Oh boy, I've done a poor job of this one. Supposed to be coming down like that, connect. And look at this, how stretched out it is. Is that what's supposed to happen? Is it supposed to be a horizontal stretch? Does that make sense now? It is horizontally stretched? Okay, so that red graph now has now stretched into the orange. Jeez. Wow. Now I think that's what's supposed to happen. Yeah.
So the math behind it would be, for this example, 1/3 divided by,
Gotcha. Absolutely. Right here, Katie. It's 1/, my C is 1/3. And we all know that means 1 divided by 1/3, I'm glad she asked. Which means what, 1 times 3, flip it over, that's where the 3 came out. That's where it came from. Make sense, guys? Woo! Now don't rush out to rate my professor and start rating me already with all these different colors. Oh, you should say, oh, professor, I like all those different colors, they're glaring at me. I'm not understanding much, but I see the different colors, I love the colors. I love your handouts, yeah. Mr. Park, I love your assistant. Yeah, we're doing a good job in here. Now, I think I've covered everything on that handout. Whew. Okay, guys, that was a task, but we did it, and I think it sort of makes sense to us. Now, I'm not going to do anything else with the transformations. I know I've seen students say, oh, professor, please, let's get that quiz started. Okay, well, we're going to start in a few minutes. I think we've done a good job tonight. Okay, now, did I finally get to chapter 2? I did not. Hang on, let's see what you're going to pick up when you leave. Oh, yeah, let's see if you did. Oh, beautiful, beautiful. When you turn in your quiz tonight, and I'm expecting a 10 out of 10 on this quiz tonight, you're going to pick up, one side is a review for the exam Wednesday. Wednesday's next week. And these are some topics, and also I think I threw in some examples for you to sort of work on.